Greetings, it's Mr. Winter back at you with another series lesson here. This one is our fourth lesson that will be covered on this year's AP exam. It's over the ratio test. I'll let you get the joke there on your own, on the corner there. To understand the ratio test, I think it's a good idea to talk about the geometric series test that we've discussed already. In essence, the geometric series test states that if I have a geometric series, in other words, a series where the terms that you add are, you go from term to term by multiplying by some value. If the absolute value of that ratio is greater than or equal to 1, the series diverges. If it's less than 1, then the series is said to converge, and then it does converge to this formula. The sum of n terms equals term initial over 1 minus the ratio. Now, with that in mind, here's what the ratio test says. It's a ratio test. Basically, it's for like a geometric series. You're determining the convergence or divergence of a series by comparing the absolute value of the ratio between consecutive terms, like between a sub 2 and a sub 3, or a4 and a5, the current term to the term after, and deciding how it compares to 1. That's the basic idea. In other words, take a look here. Ratio test, useful for series, including factorials, exponentials, especially factorials. This is a great test to use. What it says is that your summation or your series of an will converge if the limit as n approaches infinity of a sub n plus 1 over an is less than 1. What does that mean? What is an plus 1? What is an? Why am I dividing them? And why do I even care that it's less than 1? Well, let me explain. When I talk about an, that means like your current term. Let's say it's your first term, your a1. That would make an plus 1 your following term, an plus 1, or a2. So if this is a1, this would be a2. This is the previous term. This is the one after. So if the term after is bigger than the one before, what that means is that your series is getting bigger. The terms are getting bigger and bigger and bigger. Well, that's not what we have here. I have my new term being divided by the previous term being less than 1. What does that mean? It means your terms are getting smaller, 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 which it'll get small enough to where you're basically adding 0 and it will converge. Divergent is basically occurring when I take the ratio of the current term or the present term or the initial term and then divide the next term by it. So like if I take the third term and divide it by the second term and it's greater than 1, that tells me that my terms are getting bigger. And if the terms are getting bigger and bigger and bigger, it converges. The ratio test is considered inconclusive if that limit is equal to 1. Why the absolute value? I'm not worried about whether it's positive or negative. I'm only worried about the magnitude. Do the terms get bigger in absolute value? Do they get smaller in absolute value? That'll tell me what I need to know. The algebra on this can get a little tedious, so we may have to talk a little about that when we meet for class, but I'll let you do the reading here. It kind of describes what I just talked to you about right now, in that if the new term over the previous term is less than 1, it means the new term is smaller than the one before, the series is decreasing, eventually it's going to converge. If the limit of the new over the old is greater than 1, each new term is larger than the one before, and it just keeps increasing and diverges. That's the basic idea. I'm not going to read the whole thing to you. I just wanted to go over it a little bit. So, here's a series. First thing I'm going to tell you, without doing the ratio test, I'm going to tell you that this series will diverge. How do I know? It's a little thing called relative growth rate. See, like the function 3 to the power n is an exponential. It's going to get really big really quick. Problem is, n factorial gets really big even faster. n factorial, or the factorial function or operation, whatever you want to call it, is or has the greatest growth rate or relative growth rate out of all of them. So I would consider this to be top heavy, which means my terms are going to keep getting the size of the top supersedes the bottom. They're just going to keep getting bigger and bigger and bigger. But I do want to show you how to do the ratio test. Again, the ratio test works great for exponentials, which we have here, and for factorials. So first thing I have to find is, all right, what is the ratio from my a to the n plus 1 term, or my n plus 1 term over my nth term, as I go way, way, way out to like infinity. Again, when I talked to you before about an plus 1 and an, I talked about a1 and a2. No, I'm talking about a 25 trillion and then the term after that. What's happening as I go way, way, way out on this series? So to find the an plus 1 term, all I really do is take each n and replace it with an n plus 1. So what I get here is the ratio of the n plus 1 term, which means instead of n factorial, I have n plus 1 factorial. Instead of 3 to the n, I have 3 to the n plus 1. That is my n plus 1 term. All I do is replace every n with an n plus 1. Over an, well, this original is my an. The n factorial over 3n. And forgive me, this should have absolute value on it. That is my bad. Okay, that's better. What I do, little copy, change, and flip. I keep the n plus 1 factorial, the 3 to the n plus 1, and then take the reciprocal of this. Now's where the algebra gets a little tedious. Bear with me on this. I'll try to walk you through it as best I can. N plus 1 factorial. Like, if I take 7 factorial, it means 7 times 6 times 4 times 3 times 2 times 1, blah, blah, blah. So basically, I could think of 7 factorial as 7 times 6 factorial. So n plus 1 factorial is really n plus 1 times n factorial. Now, why did I write it like that? Because I want to cancel those two n factorials. I had one here. I rewrote this to make it to where it cancels. Notice here, 3 to the n plus 1. Remember when you add powers, that's because you multiplied. So 3 to the power n plus 1 is really 3 to the n times 3. What's good about that notation? Not only were we able to cancel the n factorials, we can also cancel 3 to the power n's. That leaves us with the limit at infinity, n plus 1 over 3. And the last time I checked, infinity plus 1 divided by 3 was really huge, which is greater than 1, which basically means as I go out an infinite number of terms, they just keep getting bigger and bigger and bigger. It means that the new term is bigger than the one before it, which means we diverge. Again, if this were the regular AP test and not the condensed version from this year, and this were a multiple choice question, if I saw an n factorial on top, I would tell you that it would diverge. If I saw the n factorial on the bottom, I would tell you converge. But so, next one. Again, a couple of exponentials, 3 to the n plus 1, 4 to the n, and an n squared, summation n equals 1 to infinity. Again, what do I want to do? I want to compare my n plus 1 term and my n term. So the n term is, if I go out like 50 trillion terms, what do I got? Compare it to the one right after it. So here's where the messy algebra happens again. To set this up, to find the n plus 1 term, I just go and replace every n with an n plus 1. So if I have 3 to the n plus 1, and I'm replacing n with n plus 1, that really gives me 3 to the n plus 2. And then over 4 to the n becomes 4 to the n plus 1, and then n squared becomes n plus 1 squared. So this top part right here makes my a n plus 1 term. over the original, what we had in our original problem. 3 to the n plus 1 times 4 to the n times n squared. Now we do a little cleanup, do a little keep it, flip it, change it again, and I want to try to make it so that stuff cancels. Now I know what you're used to, like we know limits at infinity. If there's something that's insignificant, you just kind of ignore it. You might be saying, well, this 2 isn't important. It is important. It's an exponent. It matters. Now, this plus 1 here isn't important, but we'll deal with that at a later time. So what I'm looking at is I have a 3 to the n plus 1, which I know I can separate with multiplication. A 3 to the n plus 2, I can separate that with multiplication, and this 2. So it's going to get a little messy, but bear with me. The 3 to the power n plus 2 becomes 3 to the n times 3 squared. Remember, multiplication means you add the powers. 4 to the n plus 1 becomes 4 to the n times 4. Again, multiplication, add powers, leave the n plus 1 squared alone, and then here we go. Now we go on a canceling fast, and when I do that, you'll see that this 3 to the n cancels that 3 to the n. This 4 to the n cancels that 4 to the n. So I get, and basically this 3 squared, or 9, will cancel with this 3 right here, leaving me with just a 3. So basically the 3 to the n's gone. One of these 3's is gone. The 4 to the n's gone. The only thing left is one of these 3's and an n squared on top. On the bottom, I'm left with just this 4 and this n plus 1 squared. Now that we don't have those n's being powers and stuff anymore, limits at infinity, remember, I only worry about the highest powers on the bottom. Like if I were to FOIL or distribute n plus 1 times n plus 1 out, my highest power would be n squared. So really, this plus 1 is insignificant. It's not a power. See, like when it's a power, it matters. When it's not part of a power, that plus 1 is insignificant. Or FOIL it all out, multiply it by 4, have a blast, you know. That's basically going to leave you with 3n squared over 4n squared, which gives me 3/4, which is less than 1. Again, according to the ratio test, when you go out to your infinite term, if the new term divided by the previous term is less than 1, that means the terms are getting smaller, 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 which by the ratio test means that it will converge. Last example. Again, taking a good clear look at it, I see n to the 99 on power on the bottom, n to the 99th power on the bottom. I see the summation from 1 to infinity of that an, and n to the 99th power, if you got to infinity, it gets kind of big, like really, really big. However, n factorial gets bigger, faster. N factorial has the greatest relative growth rate. I am going to tell you this series will diverge before I even start working on the problem. So it's kind of just to let you know if you're on the right track before you do the work. Now, that being said, if this is part of one of your free responses, just knowing what it will do isn't enough. You're going to have to write out and justify and all that stuff, but it at least gives you a little peace of mind. So again, I'm going to take the limit at infinity of the new term over the previous term and see how it compares to 1. So again, the n plus 1 term simply means I'm going to replace all n's with n plus 1's. So n factorial becomes n plus 1 factorial. N to the 99 becomes n plus 1 to the 99. Now, what I did here is a little sneaky. It's kind of what I do. I know in theory I should have said that it was this term over the original, but just to kind of save time, if you can do it, go from I'm going to have my n plus 1 term, and then instead of dividing by the original, just multiply it by the reciprocal of the original. Saves a little time. You may need that when you're doing your AP in May. So I look at this and what can I do? I would really like to make these factorials go away, but at this current moment I can't. So I'm going to play with this. Again, 5 factorial is the same as 5 times 4, 3, 2, 1, or 5 factorial is 5 times 4 factorial. So I know that when I say n plus 1 factorial, it simply means n plus 1 times n factorial. The n factorials cancel. Now, again, now that we've taken care of the factorials, any powers, whatever like that, this n plus 1, this plus 1 is really insignificant because I'm taking infinity plus 1. It doesn't really matter. And plus 1 to the 99, again, adding 1 to infinity really doesn't matter. So in essence, what I get, well, here's kind of the cleanup after I cancel it. What I really get out of the idea is the two 1s are insignificant because adding 1 to infinity doesn't really matter. I basically get n times n to the 99, or n to 100th power, over n to the 99. If you reduce it, it just makes n, which, as that approaches infinity, is infinity. It's greater than 1, which means that the ratio of the new term to the one before it is bigger than 1, which means the terms in your sequence are just getting bigger and bigger and bigger and bigger, meaning your series diverges by the ratio test. I hope that helped. We will go over it in greater detail as well. Also, I believe on Tuesday morning, the College Board is putting a video out on their video series to kind of talk about this as well. Peace out, guys.